Hello, in this session we evaluate two oxides of nitrogen, namely nitrogen 2 oxide and nitrogen 4 oxide. Welcome. Now, nitrogen 2 oxide is also referred to as nitrous oxide, and this oxide of nitrogen is nitrogen monoxide. This gas is colorless, it is odorless, it is denser than air, it is insoluble in water, it is neutral, and it does not support combustion. Now, this reflects much similar properties to nitrogen gas itself, in the sense that one, it does not have color just as nitrogen, it does not have any particular smell just as nitrogen, it is denser than air as nitrogen, it is insoluble in water as nitrogen, it is neutral as nitrogen, and it does not support combustion just as nitrogen. The only distinguishing property is that, unlike nitrogen gas, it is reactive. We saw that nitrogen gas is inert, and therefore we can test it by the nitroso precipitation, a process in which you use iron 2 sulfate, and when you add nitrogen 2 oxide in iron 2 sulfate, it forms a brown precipitate. How do we prepare this gas? To prepare this gas, we use dilute nitric acid and a metal such as copper, a metal of low reactivity such as copper or zinc. Now, in this case, we have used copper, and we find that when copper is treated with dilute nitric acid, it forms 3 molecules of copper 2 nitrate, 2 molecules of nitrogen 2 oxide or nitrogen monoxide, and water. This gas has one single application, which is the test for nitrates, using the same agents as we have seen up there, iron 2 sulfate and gong sulfuric acid, where it forms a brown ring at the liquid interface, otherwise known as the brown ring test. Therefore, we have seen clearly that nitrogen 2 oxide is an oxide of nitrogen which has identical properties to those of nitrogen gas, with an exception that it is combustible and it is reactive in that case. Next, we have nitrogen 4 oxide. Now, nitrogen 4 oxide is a brown gas, otherwise known as nitrogen dioxide. This unique gas has the ability to readily dissolve in water, forming acidic solutions. So we see that nitrogen 4 oxide is a brown gas. It has an irritating pungent smell. It is denser than air. It's highly soluble in water, forming 2 acidic solutions, namely nitric 5 acid and nitric 3 acid. It's acidic in that respect. It does not support combustion. How do we test it? Well, its color is brown and it dissolves in water, forming acidic solutions. So we can test it by its acidity and its color. Preparation. To prepare nitrogen 4 oxide, we use concentrated nitric acid, and in this case, when a less reactive metal such as copper or zinc meets concentrated nitric acid, it forms a molecule of copper 2 nitrate and 2 molecules of nitrogen 4 oxide and water. Now, what you see here is a similarity, in the sense that whenever you're preparing nitrogen 2 oxide or nitrogen 4 oxide, you use nitric acid. The difference, however, is that to prepare nitrogen 2 oxide, we use nitric acid in its dilute state, and to prepare nitrogen 4 oxide, we use nitric acid in its concentrated state. We've seen that when you use nitric acid in dilute state with a less reactive metal such as copper, it forms nitrogen 2 oxide, a colorless gas. When, however, you use nitric acid in the concentrated state with a less reactive metal such as copper, it forms the brown gas, nitrogen 4 oxide. How do you use nitrogen 4 oxide? Nitrogen 4 oxide has a varied range of applications. The first being the manufacture of nitrate salts. The second, large-scale manufacture of nitric 5 acid, otherwise referred to as the Oswald's process. The third will be the tests for organic compounds by the use of dinitrophenylhydrazine. And hydrazine itself is manufactured from nitrates, which acts as rocket fuel. Thank you. That is my description of the two oxides of nitrogen, namely nitrogen monoxide and nitrogen dioxide. In our next session, we are going to look at the physical and few chemical properties of ammonia gas and also the nitrogen tetroxide. Thank you.